What are startups missing out by not following this methodology?
You'll still run out of money, but what you're really doing is that you're running out of learning. You're not learning fast enough.
There is no backlog anymore. Every day, instead of talking about features, you talk about experiments. What do we have to experiment about today? What's our hypothesis?
Instead of planning all the things that you need to do, it's better to not plan the whole way and just plan the next step and then check like, oh, did we get closer? We went from like one deploy every 2 weeks to production to having 30 deploys per day.
If 98% of the code is written by AI, what's left of me? What I'm going to do now?
We're not doing basically any coding at all ourselves. It's 100% with AI.
Welcome to the Product Engineers podcast, where I'm unpacking the convergence of product and engineering roles in tech. Anders Fredriksson has been building startups for over 20 years. He scaled arrival guides to 50 million monthly visitors, had his AI company X acquired, and was named Sweden's most prominent internet entrepreneur back in 2007. We get into this idea of the iteration factory, that the real job of an engineering team isn't really building the product, but building the machine that builds the product. Once you see it that way, everything changes. Planning goes out of the window, replaced by daily experiments. The backlog disappears, and the question stops being, what should we build next? And becomes, what do we need to learn next? Now, take that mindset and add AI agents to the mix, and things get really, really interesting. His team at StereoAI wrote zero code themselves. It's all agents, which honestly, I'm still kind of processing. He also walks you through a simple exercise to find the first bottleneck in your own machine. By the end, you'll either want to delete your backlog or you'll find we lost our minds. Maybe both. Enjoy. Welcome to the show, Anders. I'm glad to have you here.
Thank you so much for having me.
So you've been working in the industry, you've been building startups for the last 20 years. And you also in the process of writing a book called Speed, Optimizing Startups for Speed of Iteration, where you're really dumping everything that you learn and this new methodology that we're going to talk about today. And now you're working at a startup called Stare.ai, where I think most engineering teams would find it either inspiring or terrifying when you're working there. But I want to start before any of that, before the book, before Stare.ai, really take me back to that moment that triggered you to think startups are doing it all wrong.
Yeah, so it really started with a lot of frustrating moments with past team members. I couldn't really explain to people why I thought something needed to be done a certain way. It was because I didn't have the terminology for the things that I thought were important. But so the theory behind what I've sought to figure out was this, that, if you have a known problem with a best possible unknown solution, like there is an unknown solution somewhere, but you don't know where it is or what it is. You just have an idea of like, okay, yeah, it's somewhere over there. So the hypothesis with Speed is that instead of planning all the things that you need to do to get to that unknown place, it's actually better to not plan the whole way and just plan the next step and then check like, oh, did we get closer? And then plan the next step. Oh, did we get closer? So like you do, and the faster that you can do those small steps, the higher the likelihood is that you actually end up finding the best solution. So instead of like thinking of a single solution that you think, okay, this is what we need to do, you essentially create a system or you create a machine that allows you to test all possible combinations of solutions. And then if there's only one left, then that must be the best one. But so to answer your question, the problems that I ran into was like, I was having discussions with colleagues in my companies, and they were asking me like, oh, why do I need to build this? And back then my answer was like, oh, shut up, just do it. And obviously not very good way of communicating. So that led to a lot of frustration with the people working with me. It led to frustrations from me and so on. So yeah, so there were a lot of those situations that just kept on coming back and back, and when I couldn't explain to people why doing something a certain way was important, because if you just looked at the actual thing that I was suggesting that we do, like in the small context of that, it doesn't really make sense. But then if you think about it from a speed of iteration perspective, then it does make sense.
Yeah. So what are startups missing out by not following this methodology?
I think they're missing out on a lot of opportunities to figuring out like if there's actually a product or there is a business for the given thing that you want to solve. Like figuring that out quickly will mean less time wasted, less money burned, and so on. And also creating the opportunities of actually finding where the business is in the thing that you're trying to do. So if you start with a big plan of like we're going to build this specific thing, then it might be that you shoot yourself in the foot and end up wasting a lot of time building that full thing and end to end where it works. And then like, oh, I mean, this is all like pretty basic stuff. If you comes back to the whole, Eric Ries's lean startup approach where, you just need to know the next, like there's a build, measure, learn loop, and you need to measure and you need to learn. And like the faster you can go around that cycle, the faster you will succeed or fail.
Could you describe like what a day looked like in one of the companies that you worked on? Where did you manage to kind of bring this methodology in?
With my other startup that I'm working with called Ansen, we implemented the methodology from the start of the company, essentially, and it really helps to focus the team on a particular way of working, and you can really solve problems much, much quicker than what you would with a sort of normal standardized approach to like how you build companies. One of the core principles in this methodology is that everybody in the company owns end to end. And what that means is that you don't have a super hierarchical organization where you have somebody decides, oh yeah, we have to build this, and then there's a product manager that says, okay, that will be implemented with these 5 features, and then you have code monk engineers just implementing those features and say like, oh yeah, I did the thing. So the opposite is instead that you define what's called a one metric that matters, that aligns the direction of everybody in the company. So and the direction in this context is, so you can view people in a company, you can view them as everybody in the company could be seen as a vector. So you have both a direction and magnitude. And the total vector for the business is that you just add up all the vectors of all the individual contributors in the company. And like if the direction is not aligned of those, then like your net vector becomes 0. Or like you have somebody that is pulling in the complete opposite direction, then it doesn't matter if everybody else is aligned, then that becomes a problem. So the one metric that matters becomes the compass, directing the company to like, yeah, we believe that the best solution that we're trying to find is in this direction. And the connection to the end-to-end responsibility is that everybody in the company can then come up with ideas that they believe will move that metric in, and they have the authority to implement that end-to-end. It's like you implement it end-to-end and you push that code to production and it runs and you measure and you see, did it move in the right direction or not? If it doesn't, then you roll it back or you improve it or whatever. But you really focus on on getting it out there in the hands of the customers as quickly as possible. So yeah, and it could also be like a very, very basic things. Like instead of implementing a feature one time and then pushing it out to the to production and then testing it there, like having customers test it, there's also a lot of iterations that can happen locally. So like as a developer is developing, if you own end to end, you have to understand like what is the customer's need, what is the benefit of this thing that you're trying to do. You work on your developer machine and you experience the pains that a user would experience. So there's a lot of things in there that like it doesn't necessarily like solve the problem itself. It's just a way of like how you build the machine that builds the machine in a way.
I remember from the conversation I had with Kevin, who is the CEO of Ansen. So he kind of described what are the practices that happen day by day. So, for example, he told me that there is no backlog anymore. So they removed the backlog completely. Every day, instead of talking about features, you talk about experiments. So you meet in the morning, try to understand, okay, what do we need to experiment about today? What's our hypothesis that we need to test? And then you ship stuff to production and see how it works out. There are no sprints in terms of like a scrum, so no scrum. And actually, there was one thing that stuck with me, which was the concept of daily sprints. So that was very interesting. So, someone listening right now may think, maybe even like a software engineer, can think, there is no structure at all. Like there's no process. Everything seems a bit more like a left to chance a bit, right? Because you're kind of betting about what's going to work or not. What would you say to these people?
Yeah, I mean, it is true in some sense, and this end-to-end responsibility definitely puts a lot more weight on each developer's shoulder. That now you have to do the scary thing and actually talk to the customer yourself. Like you can't just have the salespeople talk to the customer or the product manager talk to the customer. Like you should be doing that too. But I think like one example that could help explain a little bit the difference, because there's still sort of structure in terms of that you about the thing that you want to improve. So with Ansen, so before Ansen, I worked with Kevin at the previous company called Saplify. And when I started working with them, that's really where I first applied the methodology. And they're a pretty big team. They were doing like classic 2-week sprints with a backlog and so on. And after the 2 weeks, they did a deploy and so on. Pretty standard Scrum approach. They also had like a separate like the repo. The code repo was separate, so like there was a lot of things that were slow to develop and so on. But I mean, still they were releasing to production once every 2 weeks. So after the change, and I mean it's a lot of the methodology is actually of like how you change your whole coding setup. To be able to have a full end-to-end replica of production on each developer's machine. So you run the full system on your machine, and then we don't do PRs, we don't do code reviews, or I should say we don't do asynchronous code reviews, which a PR is, where you like have to interrupt somebody else's flow and so on, because it's actually much slower. So after everything was implemented there, we went from like one deploy every 2 weeks to production to having 30 deploys per day. And some people might be scared about like, oh shit, like how does that work? Like that's crazy. Like how can you verify that everything works and so on? And The interesting thing is that when you get there and you have continuous deployment, the cost of an error becomes directly proportional to how fast it is to roll back. So like if you can roll back, or like if you can fix a bug in production in seconds, like does it really matter if you accidentally push a bug? Like maybe not. I mean, as long as you can detect that there actually was a bug, of course. But so like this whole approach with this is also dependent on like the type of system that you're building, and really looking at the cost impact of a bug reaching production. Like if you have I worked with another client that did like a solar power plant, like the operating system for a solar power plant, where developers would need to have, they would have to go out to the actual physical plant, to the little computer that was there with a USB stick, and then install the update of the code. Having bug in that code is extremely expensive. So it's all relative, right? But then if you think about doing this type of approach, then that can define your architecture. So what we did with the solar power plant was that we changed the way that they would deploy code to be able to have, so that the power plant was able to automatically update if there was new code. Still, I mean, it wouldn't be 30 deploys per day for that type of system, but it was, I mean, they did like one deploy per 6 months there, and we got it down to, I think, one deploy every 1 to 3 days. So the number of improvements, or the number of possible solutions that you can test to see that if it solves your problem, like it increases by your speed of deployment.
Is there one situation in your mind where you would never use this methodology?
If you have a known solution that you just need to implement, then there's really not a lot of need for this approach. It's more about when you're working with the unknown. It's like you have a hypothesis of something that maybe solves the problem, but you're not sure. Then it's a good fit. But I mean, there's a lot of things that are already solved. Like you don't need to experiment your way of how to have a database functioning in your system. Like you don't, I mean, maybe you could experiment having different types of databases, like if you want to optimize for performance or whatever. But like for those types of problems, like I don't think it makes a lot of sense. I think all of this has changed dramatically in just the past couple of months. When you think about like, oh, what does this look like if humans are not doing the actual coding? Then it becomes even more important that you have a clear direction, because now code doesn't cost anything. Like you can write hundreds of thousands of lines of code without blinking, which means that you can essentially run super, super fast in the potentially wrong direction.
So when you say that this is not it wouldn't work with known solutions, so I think in that case, probably we don't even need to like building something from scratch, right? Because you already have maybe some products, some libraries that already did the job very well, have been tested. So in that case, it's just about integrating those solutions into the system. And for what I'm understanding, this approach will be always useful when you are facing, let's say, product problems or even technical problems that can affect the product in some way. Does that make sense?
Yeah, so like if you have a user-facing system and you don't know how the user is going to behave, like you may understand their pain, you may understand their problem, but you don't know if your solution to the problem actually helps them. Because I mean, it's a pretty classical thing. I've made this mistake so many times where, like, oh, I have this perfect system that, like, literally solves the problem that they've defined, but it still doesn't work because the users don't understand how to use the product. So I think in those scenarios, that's when it really, really helps to have a super quick feedback loop from, you build something, you test a version of like whatever, have the users actually use it, and then you test again. You've always had like UX researchers trying to do like, okay, what is a faster way of doing this? Like, oh, maybe we just have these written play cards where you like sit down with the user doing user interviews, and you have them like, oh, click here, and then you just show them a new paper board of what happens when they click there. So like you do this kind of thing, but now that that model was sort of defined when code was expensive, and like building the thing was expensive and took time. Now you can build all that like in a minute or 2 minutes, or like it's very, very easy to like actually just build the thing that you want to test.
So do startups are wrong about focusing on their runaway in this case? Like how much money they have left?
So I mean, if you move slow, or you have this plan and you execute that plan, and if you don't learn anything during the path of like building whatever it is you're building, and you deploy it and it doesn't work, then like you're gonna run out of money, and like you're not gonna be able to solve the problem, and your company dies. But there's another way of looking at it, is that in order to solve your problem, you need to learn as fast as possible. So you need to optimize for your learning speed. And startups today, instead of like, I mean, technically you'll still run out of money, but what you're really is doing is that you're running out of your the learning. So like you're not learning fast enough.
I think that's a very interesting way of saying it, because yeah, when you think about learning and not just the money side, then you can focus on building all your, let's say, processes or practices around learning faster, and not like being scared about like this deadline in the future. Another thing I was thinking is that, so going back a bit to the practical side of speed, when you are releasing so many times a day and you're experimenting so much every day, how do you measure impact?
So it really starts with the one metric that matters. And if you have that metric, and the way I define it is that it needs to be something that is impactable in a sort of daily or hourly basis. So it can't be like something like, revenue, or, some lagging metric. It needs to be a very short-term metric. So as a developer, when you sit and think about, okay, so what should I do now? You look at the metric, you look at your system, you're like, okay, what can I do? Like, oh, maybe I can, if I change this thing, or like, oh, if I make this button green, then I think that people will click on it. And I think that will impact the metric, whatever it is. Like, let's say it's, conversion rate, or I don't know, something like that. Then when you ask yourself, will this thing that I'm about to do, will this either impact our one metric that matters, or improve the speed of iteration of our system? If the question is yes to either of those, then you do it. If it's no, then for the first question, like with the will this impact the one metric that matters? So if the answer is no, then you have two options again. Either you don't do the thing, or you can also change the metric. So like the one metric that matters is something that is a living thing. You don't, I mean, in the perfect world, you would define the absolute perfect metric and you just use that forever, but that is very, very difficult to do. And it's much better to have a bad metric to start with and change it frequently as you learn, like, oh, this didn't really help. Like, we've at Ansen, we've done that like 100 times, just changing what it is that what our one metric is. So it's really that, I mean, it becomes a lot simpler in a way from a developer perspective. Instead of like picking a task from a backlog, you can just come up with ideas yourself. Or if you don't have ideas, then maybe in the, like Kevin was talking about with the daily sprint, or like an ideas meeting where you generate a bunch of ideas for the team, then you can share, and then that sparks new ideas from each of the developers or each of the people in the company, and so on. So then, like you can get input that way as well. If you're not super creative.
How do you scale this kind of experimentation as the company grew?
Well, since the employee owns end to end, it's up to the employee to track the things that they are doing, that it has the impact that it's supposed to have. In a few of the places where I've implemented this, we tried to have like a super structured experiments dashboard with, tracking the experiments over time, and like having this, statistical probability of that it was actually this experiment that did it. What I've found is that it doesn't actually matter what contributed exactly to the metric improving if it's improving. If you then change something and you're like, oh, let's delete this thing that I don't think anybody uses that, then you'll see directly that, oh shit, now our metric dropped. Like, oh, maybe what did we do? Like, oh, I removed this thing. Could that be it? And then you put it back. And like, oh, now it goes up again.
Do you hear some people thinking, yes, but this in my company wouldn't work because I have like 100 engineers. If everyone is doing this, then it's going to be complete chaos, right? So how do you think this is going to work when company also grow in size and there is more coordination, and how this can look like? Or do you think this is something that it's only, let's say, useful for startups that live into the unknown?
I don't think this is easily applicable for every company. Absolutely not. Especially if you already have an organizational structure where you have separate teams doing separate things, working on completely separate stuff. It could still work like within that separate group doing this approach internally. So you can have like the same approach internally within that team. But if you really want to have this sort of full impact way, then you have to design the whole organization around it. So it determines who do you hire. Like, you shouldn't hire somebody that only knows how to code Android apps. Like, you shouldn't hire somebody that's super specialized. So this approach goes well in hand with the trends with AI as well, is that we've been in for a very long time, we've been in a world of specialists where like companies hire specialists of somebody that is super good at this one thing. I think we're going away from that and moving into a world where generalists are going to win, because a generalist can fill in any gap they have with AI. And like, if you really wanted to move to this methodology from a existing company where you have super structured teams that only do specific things, then I'd recommend to sort of have everybody start slowly to move to full stack by adding AI as sort of the fill in the gap layer.
Yeah, it makes me think about what people usually say. Usually people that go a bit against AI, that AI can only take you 80% of the way, and that it's only 20% that counts where you actually can make a difference. But to be honest, if we can get 80% in a lot of our activities and we can give 100% in one, I think it's still good, right? And
yeah,
it's not so. I think generalists can get to 80% pretty quickly right now.
But I mean, like, yeah, totally. Like now in at Stare, the new startup, we're not doing basically any coding at all ourselves. Like, it's 100% with AI, and it's mind-boggling even to me. Like, I've been coding my whole life, and like I'm pretty good at it, I like to think. But with the experience of an experienced team or an experienced engineer, then you can direct it to say like, oh, when you solve the problem, use this, this, and this, and this, and this, and use them in this way. And I like, oh, maybe could we like if we do this and this thing in some other way, like maybe that can be a new possible solution to how to solve a given problem. And that's what we've been doing at Stare now, and it's just incredible how fast we can move.
Do you have a team of generalists mainly?
The team consists of very experienced startup founders, where everybody in the company pretty much has founded and sold companies previously. So everybody knows that in a startup, especially early stages of a startup, even though you may have your own sort of core expertise, in a startup, when you're like, I mean, we're 11 people now. In a company that size, you just do what needs to get done. Like, there's no role, there's no you just, there's something that needs to get done, then somebody gets on it. It's like I think the experience comes from that. So even though in our team now we have a lot of really like super talented computer vision specialists, but they're also very good general engineers and like super good at math. They're math PhDs and so on, but they just know how to solve problems. So it's like most of the things, like with experience, you can apply it as a generalist. And then especially with the assistance of having a second brain with an AI that does have all the specialist knowledge in the world of everything, then you just go ahead and build what it is that you need to build. And the benefit of not being a specialist of like when you're building something, like let's say that if you were a front-end engineer specialist, then when you're asking the AI to do something, you're going to have opinions on like, oh no, you have to use this specific package for this specific thing because, I mean, we have opinions. But like, does it really matter now? Like, if you're not going to look at the code, if you're not going to do it, like, does it matter what front-end package is used, what like programming language is used for a particular thing? Yeah, maybe not. I mean, there are some speed implications of like in terms of getting the AI to making it easier for the AI to get it right. But like besides that, I don't think it matters as much anymore.
When you don't look at code anymore, how do you make sure that the internal quality is still good?
I don't think it's fully solved yet, but the current approach that we're using now is that you ensure that the AI can always, or the agent can always validate and verify that the thing they were supposed to solve was solved. So the whole process as a developer working, or like as an engineer person in a startup working, it becomes much more about defining the like the PRD, or like defining the thing, what it's supposed to do, and giving setting up your system in a way so that the agent can actually verify that it was done in that particular way, or like that it actually solved the problem. Because I mean, I do that. I still have that problem daily, where the agent comes back, like, no, yeah, everything's done now, it works, and then I test it because I'm still responsible for end to end. Like, even though my agent is coding it, I'm still responsible. So I test the actual thing. I don't have to look at the code, but I test the thing. And then something doesn't work. Then you come back to the agent like, oh, what do you mean? Like, it doesn't work? And then it says the classic, like, oh, you're absolutely right. My mistake. So still happens a lot, but I think we're getting better and better, especially in terms of tooling, to be able to make the agent able to figure out that it made a mistake.
I'm thinking an engineer listening to this may think, well, now if 98% of the code is written by AI, what's left of me? Am I becoming like a prompt engineer? What I'm going to do now?
I don't really know, but the way I'm thinking of it is that there's still a lot of plumbing to do. So I sort of think that the job of the engineers becomes to maintain and build the machine that builds the machine. So your agents becomes the machine, and your engineers are the ones that oil the cogwheels, so to say, and removing bottlenecks and friction points for the agents so that they can operate properly. And one of those things is being able to verify that the thing they were working on actually worked. It's like, how do they do that? Like, what is it they're building? Can they actually see the thing? Like, is it possible that they see it? Can they have a fully running lab in the cloud that they can run in if you don't want to run it on your local host? Like, can they run everything in your full system to be able to validate that it works end to end? So I think there's still a lot of work to be done for that. Like, you can compare it with Tesla, for instance. So at Tesla, they have 100,000 people working. A lot of them, they have their own chores, but they, as I was doing research for the book, it turned out that they actually, both Tesla and SpaceX and all the Musk companies already operate with a very similar model to this, where they're extremely metrics driven. There's a super flat organization. Anybody in the team can work on anything they want. You still have your chores that needs to get done, but they work in this particular way. And at Tesla, they have like 100,000 in their different factories, but it's robots that are building all the cars. But what they're doing every day is that they're going, not everybody, but like a lot of people, what they're doing is that they go look at a monitor in the morning to see like, okay, what is our current bottleneck? Like, this is our metric. And their AI tells them that, there's a possibility to increase the paint mixing time for the red color for this thing. And then, they go as mobs. So they don't, sort of like pair programming, but with, say, 4 people or so. They go to that monitor at a particular station, and somebody says, oh, I have an idea for how we could do to implement a faster color mixing. What they then do is that they actually go to the physical robot, take that robot offline, reprograms it with the new color mixing procedure that they came up with, deploy it back into the production pipeline, and they see the results, measurements like, oh, was it faster? Was it better? And so on. If it was better, then it's automatically deployed to all the other robots doing the same thing. If it wasn't, then they pull it back. So it's a very, very similar approach. And I think this is the type of tasks that, at least for now, that we engineers can still help out a lot with. And then for every abstraction layer, like the stuff you can do expands. So I sort of see it as that, where, like, sure, we might not be doing the exact same things, like writing the same lines of code, but this is just another abstraction layer, and I'm very convinced that it will just continue in the same path, that it will sort of explode the possibilities of what we can do.
I mean, if Tesla is doing it with hardware, I think we have no excuse not to do it with software.
Exactly.
Which is so cheap to do it now, right? And I remember from our previous conversation, you mentioned something on the line that you also use agents into Stairs.ai in your startups that you're building now to also work towards outcomes, not only to build the outputs of the system, right? So you have these metrics and you're working with agents to work towards these metrics. So how does that look like?
Yeah, I mean, we haven't fully implemented everything around that yet, but I think it's definitely a possibility of, like, when you have a structured system such as agents are, even though they're probabilistic, they're relatively structured. If you could have a way to show the OMTM in a good way to the agents, then they can themselves run a Ralph loop or whatever. They run some kind of loop where they can check the metric, they can come up with ideas, implement all of them, and try them all in parallel, perhaps, or like one at a time, and see like, oh, which one was best, what worked, what didn't work, and then just reason around that, and then it could be like a self-improving thing for the product. I think we're not quite there yet in terms of autonomy, but I mean, if you look at OpenClaw and things like that, I don't think we're very far off. I just saw an interview with Stripe CEO, and he was saying that yeah, we're in the singularity now, and I can't believe that. Like I think that sort of in the same way as that when a war starts, like when a war starts, it's not defined until after the war has ended. So like when you're in it, like the start date is not set. And I think it's a similar way for like singularity, where I think there's a high probability that we're in the singularity start of singularity right now, which is very crazy and exciting and scary at the same time.
I have kids, and I really don't know like when they're gonna grow. I don't know, now they are 2 years old, but when they're gonna be like teenagers, I don't know how things are gonna look like, right? It's very weird. Like for the first time, now before me it was like, oh yeah, I can become a doctor, a lawyer, all an astronaut. Maybe astronauts will be still useful or something.
Yeah.
But yeah, it's exciting for sure. Like I'm having so much fun right now with AI compared to the pre-AI era. But yeah, for the future, it's a complete unknown. Like who knows?
Yeah. No, I definitely have those thoughts as well. But again, like if we look at history, for every major shift that has happened, like it will come with change, but it has always, so far in history, it's always created more opportunities. So it's scary now because we don't know what those opportunities are because they have not yet been defined. But like if you're willing to sort of hang on to that feeling of not knowing and being excited about that, then I think the future is super bright.
So another thing I was thinking is speed. This methodology. If you could remember one conversation with someone that really pushed back towards this using it.
I would say the biggest hurdle is probably when I tell them that you are no longer going to use pull requests. The way I look at pull requests is that it's a, I mean, as it is, it's a code review process. But from an efficiency standpoint, it's an asynchronous code review process. So what that means is that developer A does the work, they create the PR, and then they gotta forget about what they were doing and they switch to a new task. Wait for somebody, or they assign somebody to like developer B to review it. That developer is busy with something else, so they wait for quite some time to, let's say they wait, best case scenario, they wait 15 minutes until they see it and then they go review it. More likely it would be like a day, or, in most organizations, there's a lot of PRs waiting to be approved. But they would go there and check out developer A's work. Developer A has now started working on something else, and so on. Developer B makes some comments on like, oh, why did we do it this? Or you should change this and that and blah, blah, blah. Or there's a review agent or whatever doing the reviewing. But so in the manual human approach, not only does developer B gets interrupted in their work, developer A also has to do the sort of mental load of switching between two things. I guess both people need to do the context switching, which is expensive. Like it's cognitively expensive for the human. There's a time delay of when this code actually gets into production, and so on. And like I'm not at all against code reviews, but there's a better way of doing it. And the better way of doing code reviews is synchronous code reviews, where essentially you do pair programming. So when you're doing pair programming, you're reviewing the code as you go. So you're two people sitting there doing it, and then when you're done, you're like, okay, great, this is good. Then you can push it. So and like the main pushback comes like, oh, why would you do that's like so inefficient to have two people sitting on the same thing. But like if you look at the stats of people that are doing this, the quality of the output is a lot better. If you have a senior team, like maybe you don't need to pair program all the time. But in the same way, like if you have a senior team, you don't need code reviews. So like why do you keep the PRs if you don't want the other thing? And at the root of it, it goes back to the whole approach of the thing of where you want to optimize the time it takes from coming up with a feature until that feature is in production. And if you want to minimize that time, it turns out that pull requests is one of the biggest bottlenecks in that process. So one of the things that I also do with the teams when they have objections around this is that I've done a workshop where we do a bottleneck workshop for that exact process. And this is something the listeners can do for themselves. You can create a simple spreadsheet and you think about the process of coming up with a feature idea to having that idea in the hands of a customer in production. Like, what are all the steps that need to happen in there? And then, so you have you write down all the steps as rows. And then for each of the different steps, you write how frequently, like how many times does this step need to happen? And then how long does this step take? And then how many developers do you have in your team? And how many of them would do this thing times the frequency of what is done. So for instance, as an example, you can have like the, save to see latency is something that I talk about sometimes, where a developer writes a code change in a file, and you save the file. Like how long does it take until you can see that change? Like if it's a web app, you can see that change in the web app. Most modern development, you have a hot reload dev server that makes it instant. But like in some teams that I've worked with, they don't have a monorepo, so they have separate Git repositories with YAR processes, which means that if a developer makes a file change in a library in a separate repo, that they then need to import to the main product or whatever, like the time from save to see the change is like days, which is insane.
Yeah.
Going through that thought exercise of just writing it down with the bottlenecks that you have and calculating the frequency, instead of thinking that the bottleneck is the 4-hour build that is just massive. But if that is one thing that only happens once every X number of, days, then maybe that's not a big bottleneck. Whereas you have something like improving the time it takes, make the file change to see the change, changing that from 30 seconds to 100 milliseconds has an enormous impact. Because if you do that 100 times per day and you have 100 developers, the amount of time that you save is just enormous.
Now with AI, you can write code very fast. So that's even code is the bottleneck. So all the previous bottlenecks is like a multiplier, right? So if you're spitting out PRs so fast, and then it takes so long to review all of them, and I think it's completely madness.
Yeah. But even so, in the sort of save to see latency problem, if you apply that to agents, it's even more so, I think, because the agents don't have eyes in the same way that we do, where or not all of them at least, where you have a browser window that's open that using hot reload that you can see directly and so on. So you need to optimize for that. Like when they make a code change, how quickly can they see they made a mistake? And that's where things like, okay, what language do we choose to develop in? Like, what language should the model use? Because, like, do you have type safety? Can you do type checking that makes the agent be really fast at discovering they made a mistake? So all of, like, once you start defining like what it is that you're trying to optimize for, it becomes sort of self-explanatory of what you need to work on to fix.
Cursor just released a new feature where they can try things on the browser and make videos of explaining what to change, what's wrong. So I think maybe this could be like a step towards what you say, like even making the process even better. Cool. So just staying into topic about tooling and practices, what are the, let's say, top 5 tools and practices that you like to use to make the speed methodology work?
So if you would have asked me 4 months ago, my answers would have been like super strict of like, you have to do exactly this. Now is like, I'm not so sure anymore it matters. But if we, the thing that I still think matters is having all of your code in a monorepo. It doesn't matter too much, I think, about like your choice of a monorepo tool. I've always previously recommended to use NX, which I think is it's an incredible orchestration tool for monorepos of like where you get the whole dependency graph. They've sort of solved that, but lately with agents, it's not as commonly used. So agents often make mistakes of like not implementing the thing properly for NX and so on. Maybe that's solved now with like skills and stuff, but so that's one. But something in you should have a monorepo. You should have something in your monorepo that helps you easily execute tasks or stuff across all your different apps and libraries. Having separate libraries for things is, I think, super useful, but you shouldn't have to build stuff in order to use it in your app. So like the whole dependency of like being able to do that in a fast, efficient way during development, I think is very important. I think TypeScript is still a very good choice of if you want to select a particular framework for a particular language or so, I think TypeScript is a very strong contender. But again, like now with agents, maybe it doesn't matter. There are certain things that I still think matters, like selecting something where it's very easy to have full stack type safety, I think makes it easier for the agents to make fewer mistakes.
Something like a TRPC, those frameworks there.
Yeah, TRPC, or like I've been using Convex lately. But I think there's a lot of different ways that you can do it. But at the same time, now with Stair, because we're doing some pretty broad and advanced stuff running on machines or like small NVIDIA Jetson machines in warehouses on robots or whatever, it doesn't really matter. So there we have code in TypeScript, in Go, in C++, and like whatever it is that and Python, of course, and like whatever it is that solves the problem the best. So I think that should always come first, like use the best tool for the job, but then take into consideration of like, okay, how does this impact agents or humans, making it easier for themselves to discover problems early.
And most of the times, the answer is very similar, right? What works for humans works for agents. Right?
Now I've been thinking a lot about like agents as a junior developer. Like how do you help a junior developer be as efficient as possible and make as few mistakes as possible? Like if it's clear to them when they have succeeded, and when it's clear to them when they have failed, or like if something is wrong, then that developer will be more likely to be successful.
So you said monorepos, TypeScript. Anything else in terms of like even like techniques, processes?
I've been using Blacksmith lately for a CI runner, and it's incredibly fast. It's like much faster than standard GitHub workers, and it's very simple to implement. But I think having like a good proper CI/CD in place is very important. You should not. I don't think you should do builds on your local machines, because then that creates problems. So CI should be responsible for building images or whatever it is. I think Docker is fantastic. Like having having full parity between prod and development is very, very crucial, so that you don't like have some custom way things is set up in prod. With the difference being that, in dev, you want to run dev servers. So there's some people that still promote using Docker containers in dev. I think it makes sense to have the Docker containers for your infra in dev, but not the actual, like if you're running a dev server, like why spin up a dev container or like a container running a dev server? Like that doesn't make a lot of sense to me, at least. So I think that having CI/CD is very important, and ensuring that it's fast is very important. And then as you get further down the line, like how do you roll back? Because if you no longer care about if you no longer care about reviewing the code that gets pushed, stuff will break. And if you're not fast, if you're not fast of recovering from something being broken, then that becomes your bottleneck. So like making it easy from the start to like roll back, I think is super important. The way that we do it now is, for instance, we have Kubernetes clusters. So it's not for the faint hearted, but I think it's great if you know how it works. It's a very good way to have a standardized environment that can work across multiple clusters. You can set up your own local dev cluster if you want to have a prod equivalent on your local machine to be able to verify that everything works. You can set up labs. You can do a bunch of stuff with that. And then if you have something that automatically updates the image that is running in a pod, I think then you just have a new image built in CI, and then everything updates automatically. And then if you want to roll back, you tag the image that should be rolled back to, and then it just updates itself.
Yeah, thanks for the tips. I think listeners will find them useful. So, Anders, you were named Sweden's most prominent internet entrepreneur in 2007.
Yeah, way back
that was
when.
20 years ago. It's a long time. And is it fair to ask, what would 2007 Anders think of what you're building now, what you're doing right now?
I've always been super creative and like wanting to create stuff and so on, but it was until like I was 24 or like something like that, or 23, that I thought the word entrepreneur meant a building contractor, because in Swedish it's the same word for the building contractor as entrepreneur. So I didn't even know there was a thing that you could be that was an entrepreneur, which is like you start companies. But then if I look back at, even when I was, I don't know, 15, 16 or 17, I was, playing around with super early internet stuff. This is like late 90s. I was creating all these things, and I didn't realize that I was essentially creating companies, but I just didn't know it at the time. So I think that the 2007 version of me would look at my career and see that it's quite cool. Yeah, it's been a very wild ride, and but I mean the first startup that I got named that for by Internet World, it basically crashed and burned. And then I had way back there was this. Do you remember SlideShare?
Yeah.
So before it got acquired by LinkedIn, so I had after my startup failed, I wrote a presentation called 10 Mistakes You Will Make as a Startup Entrepreneur. And that got pretty viral, and so got a lot of publicity from that as well. And I think that was sort of maybe that was even the embryo to the stuff that I'm thinking about now, because the lessons I learned there, they were so painful. I mean, back then this was like just when Web 2.0 was starting, and the way you built companies, it's completely different. There was no, I mean, cloud barely existed. I mean, it started to exist and so on, but maybe it didn't even exist. I can't remember now. But there's a lot of big changes there. But the time I started off and I was the CEO, I didn't know anything about like what does a startup CEO do. And then, there was like, oh, you write the business plan. So I spent all my time writing business plans, which is, basically the complete opposite of what I suggest now. And even in that, like the 10 mistakes you will make as a startup entrepreneur presentation, one of the mistakes in there was about like writing a business plan or planning too far into the future, which is sort of the same idea here as here.
Yeah. I mean, I think when you even try to be an entrepreneur or build a company, I think it's an experience that really lives a lot in your knowledge baggage.
Yeah.
And I think it is very difficult to see any single activity into product development, like software development or even discovery, design, like in isolation. Everything becomes like a system of interconnected activities, because when you are building something, you have to take care of everything and you see the big picture. So yeah, that's a good story. And I mean, are you even a real entrepreneur if you don't crash and burn a startup?
I mean, I've done crashed and burned so many times. But yeah, no, it's now that you said it, it made me think about like how we're training neural nets today, like how we're training the AI models. It's just a bunch of numbers in a massive matrix that shift around essentially. So in a way, that's human experience. Like what we're doing when we're failing and adjusting is like we're adjusting the weights in our neural network that become and defines our experience in a way.
Cool. So before we wrap up, could you give me one thing, like one simple thing an engineer or a founder can do tomorrow morning to find the first piece of friction into their own, let's say, iteration machine?
It's probably what we mentioned briefly earlier, where with doing that sort of bottlenecks workshop.
Okay.
Define in detail like all the steps it takes to go from feature idea to having it in production, and like really go into the more detail you do it, the better. So like go into like, oh, you write code in project A, like save the file. Like, okay, what happens then? And they, or you commit or you create a PR, like whatever it is that you have in your current process. I think if you define that, then you're going to see like and get ideas of how to improve each one, or like just take one, like do the workshop and then take the one that where you multiply the frequency by the time and see like, okay, what is the biggest number? And then you fix that. And then you keep on working and you can do the workshop again, or like you do the process. Okay, what does it look like now? Like, okay, got it. Great. We got it down to this and this. And then you take the next one. And then you just work on the top bottleneck every day until like the reward is not big enough. Then start working on actually building. But no, don't forget about also actually building the product. Like if you're just creating a machine, then if that machine doesn't produce anything, then it sort of doesn't matter.
So yeah, I think this is the perfect place to end the conversation today, and surely this exercise will stick with me. I'll make it my own. So, where can people find you if they want to get in touch with you, ask you questions about what we talk about today, or just to connect with you?
You can connect with me on LinkedIn, on linkedin.com/in/Anders Fredriksson. You can find me on X. X is probably where I'm most active, and my username is @andefred, so ANDE So four first letters of my first name and last name. And yeah, I think those are the best places.
Okay.
I don't read email, so I think that would be a bad way to approach.
Right. Yeah, I'll make sure to add the links into the description.
Great.
All right. So yeah, thank you very much, Andreas, for your time today. It was great to get to know you and about your speed methodology and how you're applying it to Stereo AI, but also you did in the past. It was very interesting. Thank you very much for being on the show.
Yeah, thanks a lot.